Hello, everyone. Welcome to today's webcast. We'll start the presentation in about 1 minute. Thank you so much for joining us. Hello, hello once again, everyone. We'll start the presentation in about 30 seconds. Thank you so much once again for joining us. Hello, everyone, and welcome to today's Safety and Health Magazine webcast, Mitigating Gas Risks Through Safety, Education, and Training, sponsored by CO2 Meter. This is Alan Ferguson, Associate Editor at Safety and Health Magazine, co-host of the On the Safe Side podcast. I'm moderating today's event. Thank you so much for joining us. And before we get started, there are a few housekeeping items. As a disclaimer, the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety Health Magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. After today's presentation, we'll conduct a question and answer session with our speaker. If you have a question, click the Q&A button at the bottom of your screen, type your question, and press the send button. We welcome your questions at any time during today's event. You don't have to wait for the Q&A to begin. We might not get to every question, but the good news is unanswered questions will be forwarded to today's sponsor. Also, after this presentation, you'll be asked to complete a brief evaluation survey, and I'll tell you more about that a little bit later. Just to let you know, this webcast will be archived, so you can access it after today's live event to view this webcast and all of our past webcasts. Please visit safetyandhealthmagazine.com/events, or you may also receive a link in our post-event email. With that, we'll start the presentation from Josh Pringle, Executive Vice President at CO2 Meter.
Good morning and welcome to our webinar today on mitigating gas risks through safety, education, and training. I'm Josh Pringle. I'm the Executive Vice President at CO2 Meter Incorporated, and I'll be your presenter today. We're delighted to have the opportunity to spend this time with you to focus on the importance of developing, implementing, and repeating education and training practices to ensure your employees' safety and compliance. We'll give you a brief outline of our session today. We'll start with a little bit about CO2 Meter Incorporated, what we do and how we do it. We'll then, because my marketing folks tell me we have to give you a little bit of context about me as your presenter. Next, we'll dive into gas risks and understanding gas risks. We'll talk about some of the standards and codes as it relates to specific gases to give you some context. We'll talk about the importance of gas safety and training. We'll talk about some industry best practices, again, to give you some context for your potential application. And then we'll wrap it up with some resources and takeaways that you can use to and utilize for your specific training purposes, as well as a 15 to 20 minute Q&A session at the end. So if you've got questions throughout, write them down, prepare them. We'll be answering those in that session at the end. First, a little bit about CO2 Meter. We were founded in 2006 and we'll be celebrating our 20th anniversary here in just about 18 months. We're excited to pass that threshold because we feel like that 20-year mark ensures that people don't view us as a fly-by-night organization. We provide best-in-class gas detection, monitoring, and analytical solutions. We are the designer and manufacturer of all the devices except for a few. And we're proud of that fact. We produce more than 250 devices for thousands of applications across the globe. We are making, in some cases, customized devices for customers to ensure that their devices meet their needs and provide the solutions for their customers necessary. We're also proud that we're able to bring on new technology and develop new devices for customers, because it not only means that we're innovating for those customers and the market, but we're also able to take those technologies and work them back into existing devices so that our current customer base has the best technology possible for their needs. The name CO2 meter might be a little bit of a misnomer. Yes, we focus on carbon dioxide and we're very good at it. But we also measure other gases like carbon monoxide, oxygen, nitrogen, argon, and helium, to name just a few, because many of our customers' applications require us to be able to measure extra gases. Lastly, and we're very proud of this fact, we designed and manufacture more than 250 devices because we ship to more than 110 countries in 2023. Our devices are trusted and used across the globe by many of our partners worldwide. The last portion about CO2 meter that's important for this session especially is that one of the pillars of our business is the importance of education and training. We feel at CO2 meter that if we provide the best education possible for our potential customers and customers, they'll make good decisions, and most of the time we're going to win. We do that through intelligent operations as well as integrity. We want to be seen as leaders in the space, and we want to be seen as leaders in the space because our customers think that, not because we do. Let me provide a little context about me as your presenter today. I'm the Executive Vice President here at CO2 Meter, and I've been with the company almost 11 years. I am considered, I guess, an expert in CO2 and CO2 monitoring, and I present more than a dozen times a year across the globe to organizations, departments, and industry associations who want to learn more about gas safety, and CO2 specifically. I've held roles over my lifetime at Costco Wholesale, Reyes Holdings, the Corporate Executive Board, and at America Online. I'm proud to sit on the board of the directors of the International Beverage Dispensing Equipment Association. I sit on the Vendor Voice Committee for the Restaurant Facility Maintenance Association. I'm a member of the Compressed Gas Association's Carbon Dioxide Committee. And here locally in Ormond Beach, I chair the Ormond Beach Neighborhood Improvement Advisory Board. I'm also proud to live here in Ormond Beach, to be near my children, Emma and Evan, as well as my grandson, Mark. One of the important pieces or pillars of our business, as I said, is education. And we've derived literally hundreds of valued relationships and partnerships because of that one pillar. Industry veterans and associations will understand that their groups have used CO2 meter devices over the last 20 years to ensure not just the safety and compliance of the organization, but the safety of their employees as well. We've got industry valued partnerships in transportation, some of the airlines, food packaging, the compressed gas industry specifically, the restaurant world, brewing, agriculture, fire suppression, incubation, scientific, medical, indoor air quality, and so many others. We're going to use carbon dioxide and some of the other inert gases as sort of a understanding or learning potential today. We're going to use those as our basics to help you understand some of the risks and education and training you'll need to put together for your organization. One of the first things you'll need to understand is, after doing a safety assessment, are there actual regulations or codes that cover the gases you're using or storing at your facility? When it comes to carbon dioxide, there are actually 3 different organizations that have created specific codes or standards for the monitoring or exhausting of CO2 in an application. And here in the US domestically, nearly all 50 states have a code or regulation in place that requires it. So understanding what your specific gases are and if there are codes or standards around them is one of the first critical steps to your safety training and education procedures. As I stated previously, there's folks around the globe in thousands of applications that use gases for a variety of different commercial and industrial purposes. whether it's CO2 in a lab to ensure that an incubation system is has the correct pH balance in their incubator, whether it's helium to cool an MRI machine, nitrogen for food production and packaging, CO2 and argon in welding, CO2 in your brewery or in your restaurant to put bubbles in soda and beer, fire suppression, and so many others. With more than 1,000 different applications for a gas like CO2, you can understand when you start to talk about all the extra gases, how many different applications and opportunities there are in the compressed gas world. Let's dive into the risk and the necessary risk analysis. Again, using CO2 as sort of the formative gas of our conversation, CO2 is an odorless, colorless, and tasteless gas. OSHA does not declare CO2 a hazardous gas because in most of its applications, the gas is in lower concentrations. In an application like brewing, you'll run into a brewer. Brewers conduct what they call a sniff test. They'll stick their head in a bright tank or fermentation tank to see if they can smell the CO2 to see if it's safe in there. Not typically the best safety practice. But what brewers are typically smelling is the off-gassing of some of the components of the brewing process, whether it's barley, malt, wheat, hops. Those elements or compounds are carried off with the CO2. So that's why they say they can smell the carbon dioxide. They actually can't. Industry veterans and compressed gas industry veterans will tell you sometimes they can taste CO2, and that's because in the presence of higher concentrations of CO2, the gas will create carbonic acid in the back of your throat. It's a little bit of a tingle that you recognize once you've been in the industry a bit. But folks often ask me why CO2 doesn't have an additive like propane so you can smell it if it's leaking. And obviously the folks at Coke and Pepsi and some of the major brewers have paid millions and millions, if not billions of dollars over time to ensure that CO2 is in its perfect state. And that's what they call a beverage grade or food grade CO2. It's nearly perfect. And that ensures that whether you're drinking a Diet Coke or Diet Pepsi in Michigan or Maine or Missoula, Montana, that it tastes the same. So those folks will never want an additive added to the gas. Therefore, we've got to measure for it to ensure that if it leaks, that we're going to keep people safe. Another question that we often get here at CO2 Meter is, why don't we just measure for the lack of oxygen? And it's true, we can measure for asphyxiation. Those environments are called oxygen deficient or oxygen depleted environments. But typically, those are measured in the presence of gases like argon, helium, and nitrogen, not for CO2. In the presence of CO2, we want to measure for the specific gas. And that's because we know where the CO2 sits in the light spectrum. We can measure it accurately, quickly, and repeatedly. For those other gases, and we'll use nitrogen as an example, nitrogen is pretty prevalent in our Earth's atmosphere. A little bit over 78% of our Earth's atmosphere is comprised of nitrogen. So to see a change in nitrogen would require a very large flow over a very short period of time. To do that, we then need a mass spectrometer to measure it accurately. If you've ever watched CSI or NCIS or any of those lab programs, you'll see the lab assistant with a large mass spectrometer in the lab taking measurements. But that's about $250,000, so I doubt any brewery or restaurant's going to want a $250,000 piece of equipment just to measure the nitrogen in their environment. In those cases, we're measuring for oxygen. We're measuring oxygen deficiency or depletion, as I said. We're measuring oxygen as it goes away. We can do this because we know the molecular weight of these gases. So let's start with helium. Helium has a 4.0 molecular weight. And obviously, you know, because it makes balloons float, helium's very light. Nitrogen's fairly light as well at 14.0 molecular weight. If we move down the chart a little bit, compressed air or air outside, typical air, is going to be a little bit heavier in molecular weight, all the way till we get down to carbon dioxide, which is 44.1. It's a very heavy gas. That's why you'll see that CO2 always collects at the floor first at ambient temperatures. If you ever watched a movie where a witch is boiling a cauldron of bubbly goo, the prop person is typically using carbon dioxide in its dry ice form to create that fog that spills out of the cauldron onto the floor. That demonstrates that CO2 is heavier than air. It's important to note that different concentrations of gas are used for different applications. So this morning I went outside, as I typically do, and took a quick measurement of what the CO2 concentration is in outside air today here in Florida. It was about 435 this morning as an atmospheric concentration. That's pretty typical for our global number. Indoor air quality applications are typically measuring the CO2 somewhere between 800 and 1500 ppm based on ASHRAE standards. The beverage and brewing industry typically wanting to measure CO2 concentrations somewhere between 5,000 and 50,000 ppm. In medical or scientific applications where they're measuring CO2 in an incubator to balance the pH, they're typically measuring between 70 and 100,000 ppm. That's 7% to 10% CO2. And in fire suppression, we're measuring all the way at the top end of the spectrum. We're measuring 1 million parts per million, nothing but CO2. And that's used to put out fires in typically sensitive areas like turbines or generators where you can't put water on a fire. They're looking to push so much CO2 into the space that they squeeze all the oxygen out. For the presence of nitrogen, argon, helium, and other inert gases, there's really only one set point that we're concerned about. And that set point is 19.5% oxygen. Typical oxygen concentrations are about 20.9 to 21% in the Earth's atmosphere. If you think about that 19.5% threshold that OSHA has created, it's not very far below standard oxygen. However, OSHA has said that when oxygen in a space falls below 19.5%, you shall evacuate. There's no other standards, there's no other protocols except evacuation. So in the presence of the other inert gases that we talked about, if your oxygen deficiency or oxygen depletion monitor reaches below 19.5%, you shall evacuate the space. I just mentioned OSHA, and I think it's important that we start with the folks at OSHA when we talk about who's creating the standards and recommended procedures for education and training and safety in your workplace. OSHA is the Occupational Safety and Health Administration. It is a U.S. federal government administration that creates standards to keep employees and workspaces safe and to help remove hazards. These are the folks that create the standards that your workplace is required to meet, no matter what gases are stored, or even if there's no gases stored, OSHA is still going to be making recommendations and potentially making a visit to see you. OSHA uses NIOSH, the National Institute of Occupational Safety and Health, as their research organization. NIOSH is a group, again, of federal employees who are studying different problems and concerns and issues that help OSHA develop the data that they can use to create standards. The last group that I want to mention is the Compressed Gas Association, the CGA. CO2 meter has been a proud member of the CGA for many years, but it's a very short portion of CGA's lifespan. CGA was founded in 1913, so they've developed standards for safety and practice and procedures for more than 100 years to keep workplaces safe. Again, we're very proud to be members of the CGA. Specifically, recently in 2023, the CGA released its G6.14 standards for CO2 monitoring in near consumer applications. Again, using CO2 as our sort of standard for today's conversation, There's three organizations that have created codes or regulations around the storage of CO2. The first is the National Board Inspection Code, otherwise known as the Boiler and Pressure Vessel Inspectors. The NBIC first created a standard for CO2 safety in their 2013 edition, and the NBIC updates frequently, usually about every 2 to 3 years. Starting in 2013 in Part 1, Supplement 3 of the NBIC regulations, they've created a standard for what happens and what you need to do for monitoring in the presence of carbon dioxide when a vessel is stored inside. And I should probably say, most people are wondering, why are we worried about the boiler inspectors? And it's because, as I stated, they're boiler and pressure vessel inspectors. So they are keenly interested in either your bulk, micro bulk, or mini bulk tanks, as well as your cylinders. The NBIC is fairly prescriptive. It details where a monitor should be located. It details what set points or alarm set points a monitor should use, as well as what the audible and visual indications are for that apparatus. The next is the National Fire Protection Association, the NFPA. Roughly half the states use or reference an NFPA document for their life and health and safety codes. In 2016, the NFPA introduced carbon dioxide into its Section 55. Section 55 covers cryogenic fluids and carbon dioxide. Now, carbon dioxide is not a cryogenic fluid. It's not cold enough. But the NFPA felt that this was the best place to put carbon dioxide in with other cryogenic fluids. Today, the NFPA's Section 55 is very nondescript. It leaves a lot of interpretation open to inspectors and fire marshals to make interpretations about the code. Section 55, as it pertains to carbon dioxide, simply states that in the presence of carbon dioxide on a monitor shall be permanently installed. Section 55 of the NFPA will get updated, as again, like the NBIC, every 3 years. But through the work with, through co-work with the Compressed Gas Association, NFPA 55 will receive an update that looks a lot more like CGA G614 here in the next 5 to 6 years. The last is the International Fire Code, the IFC. The IFC is part of the ICC, the International Code Council. The ICC also develops the electrical code and the plumbing code and the building code. Starting in 2015, the IFC included regulations for carbon dioxide monitoring in its Section 5307. And it's changed slightly over the last 8 or 9 years to be updated to include some minor changes. But the IFC is very specific, much like the NBIC, about the location of monitors, their alarm set points, and what they should do if they go off. Last, let's deal with the importance of gas safety and education now. Again, using CO2 as our reference gas, it's important to understand that these incidents do happen. Whether it's the incident several years ago in Atlanta at the stadium that saw an industry veteran pass away from carbon dioxide exposure, or a small restaurant in Massachusetts, or a large restaurant at the LAX airport who experienced a CO2 leak and had employees get sick and go to the hospital. These incidents of sickness and fatalities happen nearly every day. But because they are essentially localized incidents, they're not reported out nationally. But what happens is these regional or local incidents are brought forth in conversations with folks like fire inspectors at their annual conventions, and these codes and regulations are developed to keep employees safe. They are not merely a nuisance, they are important safety factors for consideration. There's a few main areas of concern, and it really, let's start with the first one. It doesn't really matter the gas, but a confined space or an enclosed space is always a deadly concern. That space with four walls, a floor, and a roof typically is trapping a gas inside and makes it more hazardous because of someone's intrusion into the space. For a gas like CO2, we're worried about walk-in beer coolers. Worried about food production or industrial processes, fill plants, or bulk gas storage areas. Any place where this gas is stored and present can be considered an area of concern. We're going to run through several safety and education tips that are important for you to learn, understand, and use as you develop safety and training protocols and SOPs for your organization. The first tip is to conduct a safety hazard assessment. That assessment will help you determine the potentially dangerous areas in your facility, whether it's for gas stored, trip hazards, fall hazards, the requirements for eye or foot protection. Conducting a thorough safety hazard assessment is the key to developing proper training protocols and SOPs to keep your employees safe. And a safety hazard assessment should be conducted on a regular basis because your facilities change over time. If you need help developing a safety hazard assessment or analysis, you can go to the OSHA website where they've created a booklet with check boxes that they've made it easy for you to conduct that hazard assessment. Use that again on a regular basis to ensure you're updating your protocols. Number 2 is to use that assessment to create a safety program and training plan. You need the safety hazard assessment to understand those necessary areas in your facilities that can be issues. But the training plan can't be created unless you have those. One of the keys to the training plan is to bring facets or industry people in from every portion of your organization, not only to understand the full breadth of the potential issues, but also to get full employee buy-in on the creation and use of the plan. This training protocol and plan should be updated at least on an annual basis. The review of the procedures and plans is critical to ensure not only the buy-in of employees, but that you've updated the plan for any changes and hazards. Number 3, be consistent about your workplace housekeeping. Again, are you reviewing those SOPs regularly? Have you used an outside assessor to determine whether your training plans and protocols meet your hazard assessments? Have you developed a relationship with the local inspectors? And has OSHA come in to conduct a training analysis of your workplace? If so, you should be using their feedback to update your plans regularly. Number 4, specifically when gas is present, is to conduct a gas safety assessment itself. Do you understand all the gases that are present in your spaces? If you do, have you gotten the safety data sheets from your gas supplier so that they are on hand and your employees understand the risks associated with each of those gases? You can't create and use and customize a training plan and procedures unless you know exactly what you have in place. The next would be to install the proper gas safety devices so that you can ensure the safety and compliance of your facility. Referencing information again from your gas supplier or from industry experts like CO2 meter can help you not only understand the critical nature of what you're looking at in your spaces, but also the proper devices to ensure the safety of your employees and the compliance of your facility. It's important to understand the gases that you have because you'll want specific gas detection solutions based off of your needs. You certainly don't need a CO2 monitor if you don't have CO2 present, but you will need to understand if you need fixed or portable devices based off of your application and needs. Again, using CO2 as our reference gas, let's provide you a little bit of information about some of the devices that CO2 meter offers, just as relevant examples. The first is the RAD 0102-6. It's our standard 3-alarm safety device. It is either wired or hardwired into the building's electrical system. It meets all the requirements for the codes. It's pre-configured to ensure the alarm set points are actually what you need. It's got built-in relays to activate third-party devices. And it's got all the audible and visual alarms necessary to ensure you're compliant and safe. The next would be the CM900. That is the industrial version of the RAD 102-6. It's an upgraded version not only from its components and measuring capabilities and sensors, but also because of its rough, rugged exterior. It's an aluminum powder-coated finish to ensure it'll take hits from cylinders or hand trucks or forklifts. Again, a wired device, hardwired into your electrical system to ensure compliance and safety. The third is the CM7000 multi-sensor system, allowing for multiple sensors to run back to a hub or a tablet so that you can get up to 12 sensors working in an area or wired into different areas to ensure safety and compliance. The CM7000 is a great solution for those larger facilities or multi-room facilities like a brewery or a cannabis operation. Let's flip the script a little bit and talk about oxygen deficiency devices. The RAD 0002ZR, that stands for zirconium because that's the sensor we're using in the device. The ZR is again a plugged or wired device. Again, built-in relays for activation of third-party devices, meeting all of OSHA's requirements for the standards for oxygen depletion or deficiency, and all the necessary audible and visual alarms to keep your employees safe and spaces compliant. The next would be the CM902. Again, it's an aluminum powder-coated finish that allows for a little more durability. The CM902S is a stainless steel version, 304 stainless, that allows us to get into food packaging and production areas to ensure that we're meeting FDA compliance and standards. And the last, we'll go back to the CM7000. The CM7000 not only allows for multiple CO2 sensors, but O2 sensors as well. So in the presence of multiple gases, the CM7000 multi-sensor system will allow you to cover multiple gases in multiple spaces. Tip number 5 is to utilize industry resources. You may not be the experts in your specific gases or what's present, but you are an expert in your application. Find industry partners like CO2 meter and your gas supplier who can offer you expertise and resources based off of the gases you're using. Lean on those industry partners for the best-in-class information and education to help you get over that hill and hump a lot quicker and a lot more thoroughly than if you had to do that investigation and work yourself. Let's talk about some of those resources and takeaways. One of the important things to understand is it's nice to develop an educational plan and put it in place, but what actually happens if an incident occurs? How are employees knowing and acting to stay safe and keep others safe as well? And the first critical line of defense is always the proper signage. Based on the gas that you're storing or using, proper signage may differ, but it's important that you put the proper signage up in the proper places so that employees have an instant reference for what they should be doing. Another piece that's critical for signage is the NFPA 704 standard. We call it the diamond placard. It's required in most states that it goes on the entry or exit doors so that first responders understand visually in an instant what gas is present so that they understand how to operate in that space during an incident. The next is to, as I said, is to develop those industry relationships so that you can use industry resources that already exist to help you accelerate your training protocols. Here at CO2 Meter, we not only offer all the technical datas data sheets and manuals and videos to our customers, but also a significant level of personal expertise and technical support to ensure our customers are meeting the standards that they've developed or their industry has. That includes things like custom standard operating procedures. If your facility needs to develop SOPs and needs to understand how to do that quickly, CO2 meter likely has a resource that they can share with you to accelerate that process. And the last, again, I'm going to lean on our industry partners here. The Compressed Gas Association has a plethora of safety posters and documents that will help you understand the necessary requirements for the safety concerning the gases you'll be using. You can visit them at cganet.com for more information. We're delighted that we were able to conduct this webinar for you today on gas safety and risk mitigation, as well as the necessary steps and procedures for developing education and training protocols. We're delighted to have been part of this today and look forward to your question and answers over the next 15 to 20 minutes. Thanks and stay safe.
Well, thank you so much, Josh, for this presentation. And before we start the live Q&A, we want to remind everyone of the evaluation survey we're asking you to complete. The survey will open in a different screen after this webinar. And your input is important because it does help us improve our future webcast. As a reminder for our attendees, if you'd like to ask a question, please feel free to click the Q&A button at the bottom of your screen. And again, if we don't get to your question, all unanswered questions will be forwarded along to our speaker. First, question I'll get to is, and I'm gonna try to my best with all the science stuff. I don't think I was very good at science, but so CO2 asphyxiation is somewhat different than N2 or other inert gas asphyxiation, and that you have 20.9% O2 or present and you can still die. Are you aware of instances where this has happened, and are there any reports available in the literature?
It's a great question. We get it all the time. I will start with the second question first, which is, are there reports? I'm sure there are reports out there. Problem is they are localized incidents. So a local jurisdiction's hazmat team may have responded to an incident, written a report, but you'd have to find that locally. But the question and the person asked it pretty insightful. The normal atmospheric oxygen concentration is 20.9%. To get that to move down would be pretty significant for nitrogen. You'd have to have a pretty large release over a very short period of time. But the most important thing here is it's not a one-to-one relationship. So every time we push a ppm of CO2 in the room, we're not necessarily pushing out a ppm of oxygen. We're most likely pushing out nitrogen, argon, helium, something other than oxygen. So in the presence of multiple gases, it's important to understand how they'll all accumulate, operate, act, and take proper precautions. So in the presence of both CO2 and nitrogen, you're actually going to have to measure for both CO2 and the lack of oxygen. I hope that answers the question.
Sounded pretty good to me. Our next question.
And Alan, you got through the N2 thing pretty good. So.
I'm glad you clarified that was nitrogen. Our next question, do you recommend that a room that stores multiple CO2 gas cylinders for incubators be equipped with CO2 detectors or oxygen monitors?
Likely in these types of scientific applications, Alan, they're storing more than one gas, so multiple gases. CO2 is obviously the one that the person typing the question was interested in. In most cases, for incubation, they're using carbon dioxide as a means of controlling the pH balance in their grow mediums. So it's important that they're keeping that CO2 concentration somewhere between 7 and 10%, depending on what they're doing. So likely they're storing a large amount either in multiple cylinders or a bulk tank of CO2. In those cases, yes, because usually those are stored in either small closets, confined spaces, or in small laboratories The release of that CO2 could potentially cause a safety incident. So yes, I would recommend that. If they are storing other gases like oxygen or nitrogen or uh, something else that we've discussed today, then they will want to monitor for the lack of oxygen in those spaces as well. So again, much like the previous question about asphyxiation when nitrogen's present in CO2, when you have multiple gases, you have to understand how they both work, operate, act, and potentially have to monitor for both spaces. But I think the other thing on this, Alan, is one first, as we discussed during the webinar, is you have to first understand what your risks are. You have to do that risk assessment, and then you have to develop those plans to mitigate for all those risks. You can't just pick one or the other. Like my grandfather said, you can't shovel the driveway and then not put sand down. So you're going to have to understand the risk and develop a plan, then train for it. It's something that's going to take a little bit of time and effort.
So I was curious myself, is there an annual or biannual training required by any agency? And if not, is there a general recommendation for ongoing training?
There is an Alan, because it's sort of like the third rail of code, like or standards. They write the code, they write the standard, they tell you what you should be doing, but they don't have the ability to require training, and that's really a sad fact. So whether you're a first year medical student working in a laboratory, if you're a first year bartender working in and around draft beer, if you're new to the brewing world or the cannabis world or any of these places, millions of places where stored gases are present and used, um, I would hope that the business owners, managers, their safety trainers are conducting these trainings for these employees. There's nobody that better than you guys, Alan, that know that the lack of training is probably the biggest thing that puts people at risk. So unfortunately, no, there's not a requirement for training. We certainly wish there would be. Education is one of the pillars of our business. We hope everybody has sort of the same take on things. So unfortunately, it's up to each person to develop that information themselves at this point.
So if there's somebody trying to develop that information, what topics should that cover? Ideally, like the main topics.
Yeah, it's probably going to be industry specific, Alan,
Okay.
because what you need to know, understand, do, react to in the brewing world is different than it is in the cannabis world or in a laboratory, in a welding shop, or whatever it is. So it is really industry specific. But this is, and we mentioned this in the webinar, it's important that you lean on your gas suppliers in these cases to give you the information you need and help you create those trainings if they haven't already done it themselves. We work with a lot of independent gas distributors who have these training programs and protocols, I would say almost prepackaged. They just want the customer to act or ask or want to be able to conduct those safety trainings, and in a lot of cases those are probably better than anything you could pick up online, especially on YouTube, because they are going to be application specific and they're going to be industry specific and they're going to be local to your shop or lab or brewery specific. So they'll be able to talk to the specifics of any localized codes.
So our next question, considering the varying effects of CO2 exposure, what are the specific symptoms or signs of CO2 poisoning to watch out for, let's say in individuals working in confined spaces?
Um, it varies on based on the health of someone. So I always, not that I want to pick on elderly or anybody with asthma or COPD or anything like that, but folks with those respiratory conditions are going to feel the effects much sooner. Typically, we start down at lower concentrations. You might get a little tingle in the back of your throat because there's some carbonic acid being created in your mouth from the presence of something like CO2. Then you start to maybe get a little more cotton mouth. Your eyes get dry, maybe a little narrow field of vision. You might start to feel a little groggy in the head. You're going to start to feel, some nausea. then the symptoms of narcosis are going to be come on pretty quickly. Starting to feel faint. I always say, CO2 itself is one of the more dangerous gases because the worse you feel, the worse off you're going to be, because it collects at the floor first. As you start to feel ill, you're going to sit down or pass out into the hazard. Um, we're starting to get to spots where people are passing out and potentially fatalities above 3%. The IDLH, independently dangerous to life and health, is at 4%. So that's why OSHA set the evacuation number at 3%. So hopefully that gives everybody at least some ideas to what to look out for with their employees and others, to help keep each other safe.
So our next question: in spaces with some devoirs of inert gas, and you can enlighten the uninitiated me what a devoir is. Um, how do how do you determine whether it's hazard or not based upon the amount of gas and the size of the room? Are there a few straightforward equations that you can give?
So let's start with the first one. A doer is we'll call it like a mobile tank. So it'd be a tank that maybe a laboratory would have on wheels. They use the gas when it's time to refill it. They can put it in the elevator to bring it down to the loading dock. The gas supplier can refill it and then bring it back up. So whether it's a doer or it's stationary micro bulk or bulk tank or cylinders, yeah, the hazard is going to be based on the gas. So you got to understand the specific gas that's in place. And then the biggest thing to understand, obviously reference documents, like we said during the webinar, you might want to reference the CGA documents specific to those gases, because they're going to give you things like expansion rates. So for example, using a round number, every CO2 expands at roughly at 9 times its size when you go from liquid to gaseous. So you've got to understand the expansion rate of the gas and what the health effects are. So not to obfuscate an answer, but you really got to drill down by gas and by space. When it comes to something like CO2, it's pretty easy. The codes are pretty specific about this is how much gas. If you're storing X amount of gas, you have to do Y. Most gases don't have that, so that's why you've got to reference the data sheets, and lean on your industry partners to give you some of that information.
So it's doer. That's how you pronounce it.
It's like this. It's like the Scotch, Alan.
Okay. Oh, yeah. Well, I learned something new. Our next question: do you know of any scientific methods used to model the dispersion of CO2 in confined spaces, and how can these models inform safety protocols and emergency response strategies?
I know that people have tried to do this. I have not uh, seen anything that's 100% there. And the reason is because it's difficult to understand and mitigate for all the things that are in the space besides the gas. So if you take a brewery, for example, you've got to calculate the volume of all the tanks and equipment in there as well. So there's no easy way, but when it comes to emergency response strategies, the most important thing is to place the NFPA 704 diamond placard on the doors into your facility. That diamond placard, based on the gas or gases you're using or storing, gives the first responder a very clear indication of what gas is in the space, so they are able to mitigate for their own safety before they enter the space.
I was actually also curious, how do you know if a fixed or portable gas detector is best in a given situation?
Typical industry standard is if you have a known gas, known usage area, known potential for leakage or problems, the fixed gas detector is the best option. For larger spaces, for independent employees that are working around or in multiple spaces during the day, drivers, technicians who may be at multiple locations throughout the day, the portable device is best because they're going to be able to take it and travel with it. The other piece is that they may be entering spaces where there is no monitoring currently, but should be. So that it's important for the employee to keep their own safety in mind, and that portable device is the best thing for them.
Yeah, I just want to give another reminder to our attendees. If you'd like to ask a question, please feel free to click the Q&A button at the bottom of your screen. And once again, if we don't get to your question, unanswered questions will be forwarded to our speaker. Yeah, if someone has a question about OSHA or consensus standards such as NFPA, what are some resources that they can use to kind of find out more
Ooh, I'm gonna.
or to provide some clarity?
So most people, Alan, unfortunately, are afraid to talk to building, fire, plumbing, electrical officials. They feel like if they ask questions, it leaves them open to whatever word you want to insert there. We think exactly the opposite. We think your best resource is to talk to your local official, to ask the questions of them. What is required? I'm looking at building a new facility or a new lab or whatever. What's going to be required 6, 12, 18 months down the road when I open that facility, not what's just required today. You will never get that answer by looking on Google. That's a difficult answer to find if you can find it. So reaching out and developing a relationship with those local and state officials that can provide you that information is 100% your best resource. And I always say, the fire marshal can be your worst friend or best friend. Having an open conversation with them tends to lead towards the former, not the latter.
Speaking of safety codes or regulations, how do you know which safety code or regulation you have to meet?
It's likely multiple things, depending on what you're doing, what your application is, the equipment that you have. You're probably going to get leaned on for multiple compliance standards. Again, you're going to have to go to the local officials for that. Usually, that's done during plans review. They'll tell you, "Hey, you haven't complied with X, Y, and Z." But if you can get out in front of that, like I said, have those conversations. Most states adopt for example, fire, building, plumbing, electrical code as a total. There are some states where it's left up to the specific jurisdictions, but those jurisdictions still have to use as sort of an industry or state standard. So understanding what those standards are is step one, and then reaching out to those local and state officials to give you those answers is definitely number two.
Yeah, I was just wondering for like people who work in breweries or those in the beverage industry, is the CGA considered a go-to organization, or is there another industry-specific group that's out there, or an additional specific industry group?
I'm going to say CGA so many times today, Alan, that I probably should give a residual. And it's not just because we're members. They conglomerate industry expertise from across the most broad cross section of America, and they lean on their partners across the world for partner associations and organizations to do this worldwide. But CJ is absolutely the best resource, because they are putting those industry experts in a room to create those standards. So you're getting best practices from literally hundreds of member organizations and businesses in the compressed gas industry to give you the best solution.
And next question, if my bulk tank or cylinders are outside, would I still need a safety monitor?
100%. Think about it this way: the location of the vessel doesn't matter. The gas is getting used inside. The people are inside. You're going to need to mitigate for the risk. There's not really any ands, ifs, or buts about that.
So, how is implementing gas safety training different than watching a video?
Oh, I mean, the video is the easy part. You just spent 30 minutes watching a video and 25 minutes chatting with us today, Alan. But that's not it. That's precursor. It's all the following steps that we talked about that take time, patience, process, to understand what your risks are, to bring all the interested parties or valued parties into the conversation, create those standards, test those standards. Are we getting everything? And then implement those standards, and then retest them and re-understand and re-evaluate over time to see if anything has changed. So today was really the absolute tip of the iceberg. All the hard work comes after this.
Yeah, I was also curious. would you recommend having a local fire inspector or first responder visit your facility on a regular basis to understand your hazards? Um,
They're probably already there to do a yearly or annual inspection.
okay.
Um, Making sure you're there when they do that inspection is important. You want to see what they're seeing and hear what they're saying. Um, has anything changed? You know, codes and standards get updated all the time, usually every 3 years. So understanding that something may have changed in your world or your application or your jurisdiction over time is important. I'd ask them to come out on a non-annual basis, so off cycle. Hey, we're creating we did a safety hazard analysis for our facility. We want to make sure we're meeting all the standards that we understand. But is there anything else out there? Would you come and chat with us about it? I don't know that they're going to say yes to that, but they're certainly going to be open to someone wanting to learn more and learn how they want them to do it.
And as an overview, what exactly are the dangers associated with natural gas?
Ooh, first thing on natural gas is explosion. You know, natural gas is a it's tricky because it's pressurized. When it leaks, it leaks. Yeah, first is obviously explosion, but you people in places where natural gas leaks or occurs even naturally can become pretty ill in its present in elevated concentrations or its presence. Um, so again, going back and understanding what each of those gases particulars are from their material data sheets is important.
And once again, if anyone has any questions as we kind of approach the end of the hour here, if you could just type it, click the Q&A button, type your question, and press the send button. And once again, as a reminder, if there are any unanswered questions, we'll forward them along to today's sponsor. Um, I guess as we end here, do you have any closing thoughts or
You know, I think the big thing, Alan, today is first of all, we appreciate the opportunity to sponsor this and do this. I know, um, you know, some people might see this as a sales pitch. It's not really. It's really an opportunity to get some things in front of you to help you start the process to think intelligently about keeping your employees safe and keeping your spaces compliant. We hope we at least got that opportunity with folks today, and hope they'll reach out to their industry experts to help them understand how they can improve and train and retrain. And obviously, you know, we've got resources if people want to reach out to us, and if we can help. And I think you've put them up on the screen. Again, we're happy to help and assist where we can. But hopefully everybody, this is, you know, day one of a long process to get these things in place, keep people safe.
and I'll point out that the we just changed the slide over to some other ways to kind of get more information from you all and on social media and so
Alan, thanks to you and your team for putting this together. Again, we appreciate the opportunity.
we actually did have one final question here, perhaps.
Sure.
What is the risk level and recommended monitoring for CO2 argon, and I'm going to spell this word out, MUIX welding shield glasses or welding shield gases ran through the interior of buildings?
Yeah, again, welding gas usually is a mix of things depending on what you're trying to
Oh,
weld. Do.
sorry, argon mixed welding shield gases. So I want to
Yeah,
clarify.
it's you're going to need to mitigate both for the argon and the CO2. So again, the CO2 is going to be its own animal. Argon will be its own separate animal. You're going to need to mitigate for both the argons with oxygen monitoring, the CO2 again with CO2 monitoring.
Well, yeah, I think that about wraps us up. I say thank you so much, Josh Pringle, and the entire team from our sponsor, CO2 Meter, and of course, everyone who joined us today. Take care and have a safe day.